Hi, this is Mrs. Lemke with the lesson on 3.5, which is about solving systems of equations that involve quadratics. So at this point, you should have already done the warm-up problems with your group. If that is not the case, then pause the video and please go do that. Then after the warm-up, you are going to turn on the video, and I'm going to do the examples for the lesson with you, and you will need to take notes during that. Remember that you can pause and rewind. That's an advantage that video lessons don't have. That's an advantage that live lessons do not have, that video lessons do have. So we'll start out with checking your warm-up. The first warm-up question asked you to solve using elimination on the first problem. So if you recall, elimination is where you multiply through by something if needed to make the coefficients on one of the variables match. So I chose to make the x variables have opposite coefficients so that they'll cancel out. You also could have done this with multiplying the top equation by 3 and the bottom equation by -4, for example. Some other possibilities exist, but I made my x's cancel out, so these matched when I multiplied the top equation by -2. I got that y was -7/5, and then you need to substitute that number back into one of the equations. I chose the top one, and I put the -7/5 in, and then did the arithmetic there, and then isolated the x. I got that x was 17/5, and that meant that these two lines cross at 17/5, -7/5. You can have that in decimal form if you prefer, but you should have the same numerical value, the same equivalent numerical values. Okay, number 2, by substitution means that you take one of the equations. In this case, it was y was solved in one of the equations. So take an equation where one of the variables is already isolated and put that expression in place of that variable in the other. So this is saying another way to say y is 2x plus 1. So here where I have this y, I'm going to replace that with 2x plus 1. And then my work shows what happens from there. First, I distributed the 5. Then I combined like terms and moved the 5 to the other side. Then I divided by 13. So that's how I found the value of the x variable. Oh, I'm sorry, I'm misspeaking. And then we'll go up here. Y is 2x plus 1. So y is 2 the x value plus 1. And then just do some arithmetic there. And I get what y is equal to. So now in both of these problems, you got fractional values. That was something that I wanted to include in this question because sometimes I feel we're a little afraid of those. You don't need to be afraid of weird numbers. The second 2 warm-up questions were reminding us of how to graph some parabolas. So in question number 3, I see that this is in vertex form, and I can tell from the h and the k values here that the vertex is at -3, 7. So I plotted that point right here. I'm highlighting it right now with blue. And then I had a -1 multiplier, which means I'd go over 1, down 1, over 2, down 4, over 3, down 9, from the vertex. Okay, so over 1, down 1, over 1, down 4, over 3, down 9, etc. And then I connected those to get my parabola. Okay, that's a review from stuff that we've talked about in other units. In this one, my vertex is at 1, -5. So I went to that location right here. And it's right here, sorry. And then my multiplier was 2. So I'd go over 1, up 2, because it's like 1 times 2. Usually I'd go over 2, up 4, but 4 times 2 is 8. And then over 3 usually would be up 9, but I have a multiplier of 2, so that would be up 18. And that actually was off my grid. So then we just connect these, and there you go. Now you certainly can use the graphing feature of your graphing calculator to come up with these graphs. You just put the equation in your y equals, and then you can look at the table or at the graph and find some of the ordered pairs on the function. We will be working more with graphing in our next class together. All right, the last 6 questions were matching. And to do these, you basically just had to recognize some of the attributes of the equations you were given. For example, both of these had x plus 2, y equals x plus 2. I know that that's a line with a slope of 1 and an x-intercept of 2. So a and e were the two that showed that line. And then y equals x squared is our parent parabola function. So this had to go with a. And number 6, I saw this minus 2, and so that meant the parabola had to go through 0, negative 2. Okay, so that matched up. And then I looked at the picture itself to see where the equations crossed. They crossed at the places I highlighted with the smiley face. And then I just looked at the graph itself, and these intersection points were like really nice numbers, like they intersected at whole numbers. So it's easy enough for me to just see what the solution to the system is. So unlike back here where these systems had kind of yucky solutions, they're at fractions, these were at whole numbers that I could just read off of the picture. And then this last one, for that I just knew that this line had to have a negative slope. It had to have a y-intercept of 1. This parabola had to go through 0, negative 5. There's only one choice like that. And the two places where the points intersect are at negative 2, 3, and at 3, negative 2, just reading off the picture. For the last three, it was a little bit trickier. I knew that these three sets of equations had two parabolas each, so I looked for that. I used these numbers to find y-intercepts that made sense. So B is a little tricky in that the graph itself was created with tick marks that counted by 2s. But once you realize that, hopefully you see that this is the only choice that had 6 and negative 6 as x-intercepts. And then remembering that it's counting by 2s, you can see that the numbers I gave in black there are where the graphs intersect. This is the one that has y-intercepts at 1 and negative 1. And this is the one that has a y-intercept at positive 2 and at positive 1. And then you just look at the graph itself to see where they cross. So at 1, 0 for this choice. In the last picture, you can't really exactly tell where they cross. I had to use some other mathematical methods to tell exactly where these were, so I don't especially care if at this point, if you didn't know this, that's fine. We will be working with that more tomorrow, okay? But for now, understand that solutions to systems are where the graphs cross. All right, so this is a problem we're going to solve by graphing, and I'm going to start with doing the second equation because that's a line. So just to remind you that when we're looking at y equals mx plus b, this is the y-intercept, which is a point on the y-axis that the line passes through, and the number that's in this location is the slope. So I know for this problem, I go to negative 1 on the y-axis. This is the point 0, comma, negative 1. And then I go down 2 and over 1, because negative 2 is the same as negative 2 over 1. So that's a negative rise of 2 and a run of 1. Negative rise is going down, run of 1. Negative 2, 1. And I can keep doing that in both directions. And then I would connect the dots as best I can. This is going to require some adjustment, I think. Okay, the other equation is definitely not a line. I know the other equation is not a line because it has an x squared in it, and that makes it nonlinear. Okay, I'm going to erase some of this writing now, just for space. And we'll take our attention to equation 1. Okay, so that's in standard form. Some things I know about that equation are that this number at the end, when I have standard form, is giving me the y-intercept. So these 2 points, I automatically know both have this point on them. And then I'm going to choose to put this into vertex form because I think I would graph really well if I had this in vertex form. So I just move the 1 over, and now I'm going to do completing the square. So half of negative 2 is negative 1. Negative 1 squared is 1. So I'm adding 1 to both sides. This part will factor. That's what completing the square does for us. And then I can move that 2 over. And I know that my parabola has a vertex of 1, negative 2. So over 1 and down 2. So that has to be where the line of symmetry for the parabola would be, right down here. This is not a line that's in the system. It's just helping me see the parabola. And the parabola has to have another point that's over here to match that other blue point. And since the A value is 1, I can use my, from the vertex, I can use my over 1, up 1, over 2, up 1, 2, 3, 4. There has to be a matching die for that over here. Over 3, up 9. There has to be a matching die for that over here. 1, 2, 3, there. So there's my parabola. So here is my graph. It looks like the graphs just cross at -1, 0. So that's my solution. I could check that by looking at my graphing calculator here and seeing this point of intersection. I can use the calculate tool and use number 5. And the calculator is going to ask me, is y1 the first curve? And I'll say yes by hitting enter. It'll ask me, is y2 the second curve? And I'll say yes by hitting enter. It's going to ask me, do I think they cross at 0, -1? And I'm going to say yes again by hitting enter. And it confirms for me, indeed, the intersection is at 0, -1. All right. There's another couple problems here with solving by graphing. I'm going to see how long it takes me to do the rest of these examples and come back to those in just, actually, no, I'm not. Just kidding. Sorry. Give me a second. Okay, sorry, I just had to get myself straightened out there. I thought I had another graphing example, but I don't, which is good. I didn't want one. My next example is solving by substitution. So that's something that we saw in the warm-up. We want to have either the x or the y solved for. So let's take equation 2. And you could choose one or the other variable, but I'm just going to choose x to solve for. And so if I get x by itself, I'd have to move the y to the other side by subtracting it. Now I can put this entire expression in place of the x in the harder equation, the more complicated one. So we'll take equation 1, and where it says x, sorry, I am really just messing up here. That is not what I want to do at all. Sorry, we're going to solve the other direction. I apologize for making a mess of your notes right there. Okay, my apologies. We're going to isolate the y. I am just being a mess. Okay. All right, so we're going to have y equal to 4 minus x. Sorry about that. If you wrote like just a little bit more of the step I just erased, you'll see why we had to do that. I'll explain more in just a second. Okay, so we're going to put that expression in place of the y. All right, sorry, folks. Okay, so x squared plus x and then minus what I have for y. It's important to pay attention here to having parentheses around that whole expression. Okay, so now let's pause and think for a second about why I messed up at first. This entire thing that I just wrote in red has only one variable in it. If I did the substitution the other way, I still had x's and I had y's, and that doesn't help us. So that's why we had to go the way that I have it now. I'm sorry about that. Okay, so x squared plus x, and then this negative can go with both of these guys. Needs to go with both of those. And then we'll combine like terms, so I'd have x squared, there's 2 x's. I'm going to add this as a 1 over to this side, right? And I'll have minus 3 equals 0. Okay, now I'm going to try to factor this. I think it factors. So I need an x and an x to get an x squared in the front. My back number is minus 3. So that's going to be a 3 and a 1. And then there's going to be some plus and minus thing here to make the signs work out. Then I look in my middle term, which is positive 2x. So I know if I were to multiply this out, I'd get 3x here, I'd get 1x here. So the way to get positive 2x is to have this be positive and this be negative. So that means that the plus is carried by the 3, The minus is carried by the 1. And positive 3 times negative 1 is the negative 3 that I have in back underlined in yellow. So now x plus 3 equals 0, or x minus 1 equals 0. If the first statement is true, x is negative 3. If the second statement is true, x is 1. Both of those are solutions. I'll come back over to the purple writing, and you'll see that y has to be 4 minus my x value. So if x is negative 3, y comes out as 7. Y is 4 minus my x value. So if x is 1, y turns out to be 3. So the two places where these graphs would cross are at the locations I just circled in red. That's doing that with substitution. The third method I want to remind us about is elimination. So in this problem, it would be awfully nice if I could get the y's to eliminate. See right here? Then everything else is an x variable, and I could deal with that. It's luckily set up really nicely as it stands. If I add these, the opposite of y plus positive y is going to make 0. So I'm going to add them just how they are. If they didn't cancel out automatically, I could multiply through by something to make them cancel. Okay, so now I have 3x squared. The plain x's added up to negative 3x. The y's canceled, and negative 2 plus 0 was negative 2. So I just added all the things that are like terms, like straight up and down like that. Okay, so now I need to work with this equation. I've got 3x squared minus 3x. I'm going to add the 2 over, so I have a 0. I thought for a minute I might be able to factor out a 3, but that doesn't work with the 2. Maybe this factors, so I might try that. Okay, so that's a way to get the 3x squared. And so now the 2 could either be a 2 and a 1. Let me think about if that works. 3x, 2x, nope. Or maybe I could have the 2 and the 1 switch. And this would be 6x, 1x. That's not going to make 3x. So it looks like this doesn't factor. So I'm going to go to quadratic formula. So x is the opposite of b plus or minus the square root of b squared minus 4 times a times c over 2 times a. I work this out, I get 3 plus or minus, let's see here, this is 12 times 2 is 24. So I have 9 minus 24. Negative 13. No, 15. All over 6. And then this gives me complex solutions. So 3 plus or minus, take out the I, root 15 over 6. Now to get the y for this is pretty hard. So I'm going to tell you right now that I think in a situation like this, I would only ask you, instead of solving, I would ask you to solve the system by elimination. And if complex, then you can quit. Because what this is telling me when I get a complex solution is that these two graphs don't cross. We know the graphs don't cross. You don't need to go ahead. Whoops, I don't know what happened there. You don't need to go ahead and find the y, because they don't cross. Okay, so complex, then you can quit. You don't need to find the other variable. All right, there are 3 problems here for you to try. I'd like you to pause the video and then try the problems and then come back and see if you were right. Okay, you have to pause the video though and try them by yourself. Did you hit pause? Okay, here are the solutions. You should have tried them by yourself first though. So I'm going to scroll a little bit so you can see number 4. You should have gotten the answer of 2, 0. In number 5, you work this problem. This is a lot like the last example I did with you. And you get complex numbers. And so therefore you can say, therefore graphs don't cross. And in the last problem of these 3, you can see that I did this by adding them, and I used elimination. I got x was 0 and x was negative 4/3. But you know what? That's not done, because what did I forget? Finding the y's. So here are the y values I should have found. Okay, once you find out that x is 0, y is 2, because x squared plus y has to equal 2. And then when x is negative 4/3, x squared plus y equals 2, gives me 2/9. So the ordered pairs that you should find are these right here. Okay, we're going to do one more problem together. So this says solve by substitution. We're going to put this in place of the y. So I've got x squared plus, this is y, squared equals 10. So I'm writing equation 1 with equation 2 inserted into it. Then we need to multiply this out. This part we're going to use FOIL, multiplying 2 binomials together. So this portion is going to give me 9x squared. The inner and the outer will each give me negative 3 times 10, so that's negative 30x. So altogether negative 60x. And then 10 times 10 is 100. I also have an x squared up front. I also am going to subtract that 10 over to the other side, so I have 0. Then we're going to combine like terms. So I've got 10x squared minus 60x plus 90 equals 0. I'm going to factor out 10 because these numbers are awfully large and they're all divisible by 10. And when I do that, I see an old friend that, oops, sorry, I wrote my parentheses in a weird spot. When I do this, I see an old friend. I know how to factor this guy. We've seen him before. 10 just carries along. This is x minus 3 times x minus 3. So now I can divide by 10. I get that x minus 3, quantity squared, has to equal 0. The only way for that to be true is if x minus 3 is equal to 0, which means x equals 3. So now, remembering that I need to solve for my other variable, if x is 3, y equals negative 3 times 3 plus 10, which is 1. So these two equations have to intersect at 3, 1. Okay? Good. All right, so there are a couple more problems here. I'd like you to pause the video and try those, and then come back for the answers, and you will be done. Did you pause it? Seriously, try these by yourself. Okay, I hope you tried those by yourself. Here you can see in number 8, I took negative x plus 4 and substituted in for y squared. Working the problem should give you that x is 0 or x is 4, and then substitute back in to find the corresponding y's, and you get 0, 4, and 4, 0 as the 2 points of intersection. On the other one, you work this out, get a nice quadratic, but the quadratic gives you complex solutions. So you have what x equals, but x is complex. So that tells me the graphs don't cross. I'm going to scroll back up here in case you need to see something. Feel free to hit pause on your video if you need to look at something for a longer period of time. In summary, your homework is to do Big Ideas 3.5 Day 1. In our next class, we will spend more time on 3.5. We'll focus a lot on graphing and using the calculator. And make sure that you know the next assignment, obviously, after this is going to be 3.5 Day 2. But for tomorrow, 3.5 Day 1. Thank you so much.